My name is Dr. Rudresha. I am a expertise in thermal power engineering. I'll be teach today Bwssb junior engineering exam, competitive exams. I'll be explain. Please, everybody should be subscribe my channel and like and please comments whatever doubt is there. Please, my channel is very old channel, already 10 years old channel, but till not that much level of famous. Please everyone in academic channel and study channel also please subscribe and like. See today started 24th question. 24th questions. The expansion ratio. The expansion. The expansion ratio. The expansion ratio in isothermal process. In isothermal process. Isothermal process. Isothermal process where V1 equals volume at the beginning of the expansion, volume at the beginning 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 of expansion and V2 equals volume at the volume at the end of expansion 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 is expressed by see the question, the expansion ratio in isothermal process where V1 is equal to volume at the beginning of expansion, V2 is the volume at the end of the expansion. The ratio V1 by V2, second one V2 by V1, V2 by V1 in second one, and third one V1 plus V2 denominator by V1, and fourth one V1 plus V2 denominator by V2. Please look at here this question. This question will be the expansion ratio in isothermal process where V1 is equal to V2 at beginning of the expansion, V2 at the volume at the end of the expansion ratio. See, in isothermal process, P1 V1 denominator by T1, this is the PVT relationship, P2 V2 by T2. See what is there here. In isothermal process, temperature remain constant T1 by T2. P1 V1 equals P2 V2. You want to write it P1 by P2 is equal to V2 by V1. The answer is V2 by V1. The second one is answer is correct. See, the expansion ratio in isothermal process. Isothermal process temperature totally constant. Temperature is totally constant. Volume at the beginning and end. V2 volume at the end of the expansion by this is the engine. This is the engine. This inside you have in P1 V1 by T1 in the beginning. After entering the fuel to start burning, then that is the P2 V2 by T2. That is the end of the expansion. This the answer is second one. This is the correct answer, V2 by V1. This is the correct answer. See the next question. The next questions. I will start at the next question. The question 25th question. 25th question. In four stroke cycle, four stroke cycle, petrol engine, in four stroke petrol engine during the compression stroke, during the compression stroke, dash. See, in four stroke cycle petrol engine during the expansion stroke, there are four stroke is there. First will be suction stroke, next compression stroke, then will be expansion, then will be exhaust. See, the inlet valve is open. The first question, inlet valve is open. Second one, exhaust valve is open. Exhaust valve is open. Third one, both the inlet and exhaust valve, both the inlet and exhaust valves are open. Both the inlet, fourth one, both the inlet and exhaust valve are closed. See here, in the four-stroke petrol engine during the compression stroke, see, this is the engine. There are two valves. This is the inlet valve and this is the inlet valve. This is the outlet valve. See, when you enter the petrol engine means you have in a petrol with air fuel mixture. That is calling about air fuel mixture. That is calling about rich mixture and lean mixture. Rich mixture means to compare the oxygen content more in the petrol. Okay, that is calling about the rich mixture. Once enter the fuel inside the engine, then that will be compression stroke. Both the inlet and outlet valve are closed. Both inlet and outlet valve are closed. That is calling about compression stroke. 26th. A diesel engine has the compression ratio approximately. A diesel engine has compression ratio approximately 0.5 approximately form first one 5 to 10, second one 15 to 25, third one 35 to 50, fourth one 40 to 55. See here, the diesel engine has compression ratio approximately 5 to 10, 15 to 25, and next 15 to 25, 35 to 50, 40 to 55. See here, diesel engine compression ratio approximately 14:1, means 15 to 25. The compression ratio of the diesel engine has a compression ratio that is approximately range, this is 15 to 25. Next, 27th question. The difference between dry bulb temperature and wet bulb temperature. The difference between dry bulb temperature and wet bulb temperature. Wet bulb temperature is called, see what is meaning by dry bulb temperature and what is meaning by wet bulb temperature. To measure the temperature from the atmosphere in the wet condition. The wet condition means you have in a wet class. That temperature indicated in wet bulb temperature. You have in an ordinary thermometer to measure the temperature, that is calling about the dry bulb temperature. That is what is definition of the difference between dry bulb temperature and wet bulb temperature. This is the wet bulb diffraction. Wet bulb depreciation. See, the first one, dry bulb temperature. Second one, wet bulb depreciation. Dry bulb depreciation. This is calling about depreciation. Wet bulb depreciation. Third one, dew point temperature. Fourth one, degree of saturation. See, what is calling about wet bulb depreciation? Dry bulb temperature minus wet bulb temperature. This is calling about wet bulb depreciation. The correct answer is wet bulb depreciation. 28 questions. The relative coefficient of performance. Is equal to the relative coefficient of performance. What is meaning by COP? COP by means coefficient of performance means refrigeration effect by work done. That is calling about COP, coefficient of performance. Coefficient of performance by means COP is equal refrigeration effect. Refrigeration effect denominator by work done. Denominator by work done. That is calling about COP. See here, what is meaning by relative coefficient of performance? The relative coefficient of COP. The relative coefficient of performance means first one is theoretical COP denominated by actual COP. Theoretical COP denominated by actual COP. Actual COP. Second one, actual COP denominated by theoretical COP. Actual COP denominated by theoretical COP. Theoretical COP. Third one, theoretical COP plus actual COP. Theoretical COP plus into actual COP. Actual COP. Fourth one, theoretical COP plus actual COP. Theoretical COP plus actual COP. Actual COP. See, what is the formula for relative COP? Relative COP. Relative COP is equal to theoretical COP. Theoretical COP denominated by actual COP. Theoretical COP. This is the formula for relative COP. Theoretical COP by actual COP. This is the correct answer. Theoretical COP. Actual COP denominated by theoretical COP. Actual COP denominated by theoretical COP. Theoretical COP. See, actual COP means you coming some values. Suppose COP values will be coming 4. When using the formula means that is H4 minus H1, H3 minus H2, H1. This is the formula for theoretical COP. Actually, actual COP denominated by theoretical COP. It is calling about relative coefficient of performance of COP. See, this is the relative coefficient of performance is equal to COP is equal to refrigeration effect by work done. The correct answer is actual COP denominated by theoretical COP. Actual COP denominated by theoretical COP. See, in actual COP, always the values is coming actual COP denominated by theoretical COP.